Hey everyone, in today's video we are going to see implementation for logistic regression in Python. Logistic regression is a machine learning algorithm used for binary classification. It estimates the probability of an event occurring or not based on a given dataset of independent variables. So let's go over the code. So first we need to import the relevant Python packages like NumPy, Pandas, Matplotlib, sklearn model selection, and sklearn datasets. So the activation function that we use in logistic regression is the segment function, which takes any real value as input and outputs values in the range of 0 to 1. So 1 is divided by 1 plus the exponential number of minus x. So now let's go over the logistic regression class. In the init function, we set the model's parameters like learning rate, max iterations, and precision. The second function is the hypothesis function that predicts the class of a sample based on the weights and bias that we found during the training process. And since it's a binary classification, we put the hypothesis function inside the segment function. So the results will be between 0 and 1 and will represent the predicted class likelihood. Next, we have the loss function, which is the negative log likelihood in this case. So h is the hypothesis results, or in other words, the predicted values. Then we set a to be minus y multiplied by the log of h plus a small epsilon value minus y minus 1 minus y multiplied by the log of 1 minus h plus epsilon. The epsilon value is in case the hypothesis results are exactly 0 or 1, and we will get error trying to do log on 0 value. Then we fill all the null values with 0 and get the mean value. So the gradient function is a derivative of the loss function. So we get the hypothesis result, and then we get the absolute value of h minus y and multiply it by x. Next, we have the split data function that gets a dataset and batch size and split the data into small batches. Because we are going to train the model with subsample of data each time, the advantage of batch training is that it provides the best compromise between computational efficiency and the number of updates per epoch. The fit function gets the train and validation sets and the batch size. We initial the weights and bias with zeros and split the data into small batches. So then we go over the data max iteration times, and in each epoch we go over all the batches and perform gradient descent to minimize the loss, and we update the weights and bias accordingly. And each iteration we also calculate the loss for the training and validation sets with a negative log likelihood function, and also the accuracy for the train and validation sets as well. Then we check if we can early stop the training. In this case, the condition will be if the loss is smaller than the precision parameter we set in the beginning. Once the training ends, we return the loss and the accuracy of the train and test sets. The predict function calculates the likelihood of the classes, and then we just set the threshold to be 0.5. If the predicted value is bigger than that, the class will be 1, otherwise it's 0. And we also have accuracy function. Okay, now it's time to test the model. So in this case, our dataset is the iris set from sklearn. But as you can see, this set have 3 classes, and we need dataset with 2 labels. So for the sake of this exercise, we change the target. So now, if the original label is not 0, the label is now 1. Then we can plot a new dataset. You can see that now it has 2 classes. Then with the model selection, we split the data into train and test datasets. The test set will be 20% of the data. And then we define and train the model with batch size 16. Once the training is done, we can plot the loss and accuracy to check if this model performs well on our data. So that's it for logistic regression. It's important to know that logistic regression is not a solution in high-dimension datasets, and it also cannot handle non-linearities in the data. Logistic regression is good for simple, low-dimension datasets, and also the predicted parameters gives us information about the importance of each feature. So that's it for today's video. Thanks for watching.